Okay, so talking about the network fundamentals. So exactly like how we have discussed yesterday, the network in past and today there is a drastic change and there is a drastic demand in the technology which completely got changed and we are in the like still these technologies are getting increased. We haven't stopped with the 4G. Now there is a new technology is on the way. It's called 5G and it goes on, right? So yeah, so in that, being network engineer, now we need to understand there are what are the network devices that currently it is available to us, and what are they, and that we need to first of all we need to understand that. Okay, so in
Right.
terms of networking device, actually there are two different main classification that we can say that one is network access device
Okay.
and one is network infrastructure device. If you want to take a notes, you can.
Okay.
Okay. So, okay, what are these network access device and network infrastructure devices? Usually, if you see the network, basically an enterprise, the network, how does it look like? Is like usually they'll have the router. Usually, why I'm drawing in circle? Why? Because router is always mentioned like this. Okay,
Okay.
this is a iconic representation for router, and
Okay.
this router will be connected to the switch. And how we will mention switch? This is iconic representation for switch,
Okay.
and there will be the end host, which can be a laptop or desktop or servers or printers or IP phones, whatever it is. So this is how usually the normal enterprise network looks like.
Okay.
Okay. So in this actually, which are network devices and which comes under network access and which comes under network infrastructure are like I can consider switch
Hmm.
as an access device or hubs or as an access device and for network infrastructure device I can consider routers and firewalls.
Okay.
Okay. So what is switch, what is hub, and what is firewall, and what is routers? And here, if you see, I haven't involved something, the devices like personal computer, laptops, servers, and printers. If it has a network port which able to connect to the network, those printers that I am talking about. And
Okay.
what else I can tablet if it has a Wi-Fi connectivity where we can start browsing it, and the
Okay.
smartphones, all of these devices. So basically, if I ask you what is network, what could be your definition? So I could expect the answer something like the network means two or more number of devices that are connected together to share the available resources. This is what actual the definition of the network in a simple manner that we can say. Okay.
Okay.
Okay. So what does it mean like two or more number of devices? Why I'm mentioning two? I can mention three or four or five. But why I have mentioned as two is there is a reason for that. Let's say that if I want to
Hmm.
do communicate, I cannot communicate with me, right? Okay, I can think of myself. Actually, if I want to go and communicate, I need to go and communicate with someone, right? So to make that
Hmm.
communication, I need one person, right? So at least if
Right.
there are two-person, they can communicate each other. That's why I mentioned minimum two, right? And
Hmm.
also, it does not mean that he can only communicate to that one person. He can communicate to n number of person. That is why two or more number of devices that are connected to the together to share the available resources. What is that available resources? That let's say that you want Avenger latest the edition of that movie. If I have that movie, then only I can share with you. If I don't have, I cannot share with you.
You can share.
Right?
Yes.
Yeah. So that is what the resources that I mean. The resources which is available only that you can share. The resource
Mm.
which is not available, that you cannot share. For the technical understanding, if I want to say, if you want to take the printout, you should have the printer in your network. If there is no printer, you cannot take the printout from that.
Printer out. Okay.
Right. So what does it mean, the devices? So what does it mean by devices? I can say everything is device, right? All the electronic items like PC, laptop, including fan, air conditioner, washing machine, whatever it is, all are devices. So which
Mm.
devices that I'm referring to here?
One that can communicate in between them.
Exactly. So how we can say that that device can communicate? Why fan cannot communicate? Why PC can communicate? How we are differentiating that?
Because it needs to be able to talk to each other. Without talking, you won't be able to communicate.
Absolutely. So in networking world, if they want to communicate, there is something in the need of how we are communicating with the language. The basic need, they should have something called the MAC address and the IP addresses, right?
Okay.
So where we have the MAC address and where we have the IP address, then only the device understand the devices whichever understand the IP protocol. That
Mhm.
devices only that we are referring here as a devices in the networking terminologies.
Mm.
Okay, I cannot assign IP address to the ceiling fan or table fan or the the washing machine.
No.
Maybe in future, if it is automated and it is very well advanced,
Yeah,
like
like
what are the
like
technology?
like
Yeah,
Alexa and all those things that are coming. Yeah.
yeah, might be. Maybe in future that we can expect, but not today. So that is why these devices, hope you have understood. The devices which understand the IP protocol, those are the devices that I'm referring to here.
Yes.
Okay,
Yeah.
great. So this is what the basic understanding of network, and why I haven't involved these devices in either of these categories. Why? Because in networking, actually, if I'm speaking, you're able to hear it. Okay, we are not next to next, that we are directly speaking to each other,
Yeah.
right? In between, like, there are multiple medias or mediums that are helping us to communicate, like my head jack and my then internet connection, again
Yes.
my laptop and whatever it is, and ISP. In that, like that, there are some medias to which facilitates the communications.
Mm.
Okay, so those are these categories. Actually, these devices, they are not generating the data, they are just uh, transmit and receive the data.
Right. So in
Okay,
other
so
words,
who
they're guiding it basically.
exactly? Yeah, usually they guide it. Okay, they don't own the data, just they will transmit and receive the data. But actually,
Yeah.
who is originating the data is these guys. Either PC, laptops. From laptop only, we are typing www.google.com, youtube.com, facebook.com. So from the
Yes.
laptop, we are generating the request to that particular server which is available in the internet, right? So
Okay.
these are the one who actually initiate the communication and terminate the
Uh,
communication. But the
right.
network access device and the infrastructure device, they don't do anything with the data. They only know how to form the network so that the end
Mm.
host can communicate from source to the center.
Right.
Okay. So what
Okay.
does it mean, a network access device? I have told you there are two things. One is switch and one is hub.
Mm.
Actually, these devices will sit in the front place where do they have the connection directly to the end host. Okay. Actually,
Mm.
they facilitates the end host
Mhm.
to form a local area connection, LAN. Okay.
Okay.
Using this device, these
Mhm.
end hosts can communicate themselves,
Right.
and also they will help to take their request out to the internet to speak to some servers in the internet, like YouTube, Facebook, whatever it is.
Okay.
Okay, so at first place, so he's the first point who facilitate to join the network. That's why it is
Mm.
providing the access to the network for the end host. That is why we are
Oh,
telling this as a network access device. Here either
okay.
we can use switch,
Yeah.
bridge, there
Mm-hmm.
is something called bridge was there, but as of now there is no more. It has been
We
replaced
don't
by
use it anymore.
switches. Yeah, that's
Okay.
why I haven't mentioned. You just
Mm.
need to understand what is hub and what is switch. Either we can
Yeah.
use here hub or switch. Okay.
Yes.
So what does it mean by now network infrastructure devices? Let me just remove this. Okay. The simple term, let's say that now I have one office in New York and one office in New Jersey,
Mm-hmm.
and I have told you like they have the basic setup, something like router, switch, and the end host, right?
Mm-hmm.
So since New York and New Jersey, they are not, like very near to each other, they cannot lay
Mm-hmm.
their cable their own between these two different offices. So they
Mm-hmm.
need to be having some help. They need to get some help from ISPs, those who can provide the connection between these two offices so that these two offices, they can communicate each other. Okay.
Mm-hmm.
So whose help that we can seek is the ISP. Might be whoever it is, AT&T or Verizon, whoever it is. Okay. If
So
they got the
IS
connection.
so the ISP is the internet providers, yes?
Exactly, internet service provider who
Mm.
actually serve the customer by serving the internet.
Right.
So without the internet, these people cannot communicate each other. Why? Because they can communicate if they have laid their own cable from their
Mm.
New York office to the New Jersey office, but the government won't allow us to dig the roads for our own purpose to lay the cables, right?
Yes.
But ISP do have their permission, so that's why they are called as ISP. Why? Because they are world widespread everywhere, so they can
Yeah.
help us to connect wherever we want by using some spending some pennies.
Mm.
So okay, so which devices help us to connect from one network to the other network? Basically, that is called as a network infrastructure device. So this router actually helping me to take my LAN traffic, local area network traffic,
Mm-hmm.
to completely the other network
Mm-hmm.
in the internet or somewhere else. Okay.
Mm.
So router helps to communicate from one network to other network.
Right.
You can just write it. It is a main thing that you need to understand at the foundation level.
Mm.
Helps to communicate between different networks.
Mm.
How about switch? It helps to communicate within the same network by forming the LAN connection, LAN connectivity, local area network.
Okay. So switches deal more with local area networks,
Exactly.
point point to point. Yeah.
Uh, uh, it is not point to point that you can say. Why? Because see, there are multiple devices accessing the one switch, right?
Mm.
So it is like distributed for multiple end devices. It is not for
Yeah.
yeah. If you
So
say
it's like two or three in one. You have the router, the switches, everything in one. Yes.
exactly, it is a multi-access device you can consider.
Mm.
Okay. So that is why we call switch as a network access device and router as a network infrastructure device. Actually, without
Okay.
router, I cannot communicate from New York to New Jersey and New Jersey to New York.
Yes.
Just by having switch, I cannot do that. I need a router to route
A
my
router.
traffic from my
Hmm.
local office to the remote office.
Okay.
That means my local network to the remote network.
Right. Which is
So
the wider area network.
exactly.
Mm.
So what does it firewall? Where does it come? So firewall again is a device which is basically for the mean of security. Usually we'll have the firewall at the edge of a network where our traffic leaves. Okay, and here
Okay.
we have. Okay, this is how the firewall looks like.
Okay. So it
Not
sits in between where the traffic leaves out. Yes.
exactly to protect. Actually, where do we have our security guards? Not inside the house, right? Outside the house, right, to protect our house. The same
Right.
way, like we are protecting our network by keeping a firewall out in the edge of the network, actually, where our traffic leaves, and actually from where the traffic from the internet gets into our organization network.
Right.
So this is where the firewall will be placed, so that here we can enforce the policies, which are the traffics that I need to allow, which are the traffics that I need to not to allow, all the things that I can put so that it acts like a security guard to protect our
Right.
network.
Right.
So again, why it is under network infrastructure device? It is not under network access device. Why? Because again, it is facilitates the communication between two different network. It is not doing you know it is not doing dealing anything with the local area network, right?
Yeah.
It is dealing with uh, two different network. That's why it is
Yeah.
under uh, network infrastructure device.
Infrastructure. Okay.
Exactly. So, is there any doubt in understanding these two terms?
It sounds very clear.
Yeah, great. So let me just remove everything whatever we have discussed. So we'll just move to the next one. So this is a basic network devices actually that will speak in
Mm.
terms of uh, networking environment. So
Yes.
now we'll see actually what, don't worry about what is hub, what is which. I will be covering on that later chapters.
Mm-hmm.
And let me just now go with the network topologies.
Okay.
So when I'm talking about topology, there are actually two differences. One is actually uh, physical topology, and one I can say it's a logical topology.
Okay.
So basically, what does it mean? Topology means what actually?
Mm-hmm.
So let's say that you have a plan for this weekend to go for some vacations. So what you do, you'll draft all the things. Okay, I'll start from point A. Then before starting the trip, let me check the point B. Then after done with point B, then what I need to do at the point C. Then where I need to go and where I need to meet, or to whom I need to meet. So all these things that you will draft yourself, right? So there is some procedure or there is some structured format or the things what you follow, right? So that is a topology, right?
Mm-hmm.
So here in networking terminology, what does it mean? Physical topology and logical topologies. Let me just bring one small example. Something like so this is your house, and you are using your laptop, and this is your PC, and you are also having a Wi-Fi here, and also you got an internet connection from a service provider, and let's say that now you are trying to access a Google's web page and a
Mm-hmm.
Facebook web page and a YouTube web page, whatever it is, some servers over the internet. The only the
Mm-hmm.
thing what you know is like uh so let me okay, you are connected wireless with your Wi-Fi,
Mm-hmm.
and you will be having some physical cables coming into your house from ISP,
Mm-hmm.
right, to the router, and all these servers are available over the router, sorry,
Mm-hmm.
with the ISP, right? Let me just name it something like Google, YouTube, and Facebook. Okay, as per your knowledge, what you think is when I'm typing www.google.com on your laptop or the desktop, it is going to your Wi-Fi, and from Wi-Fi it is going to the ISP. And ISP is helping out me to get the request to that particular server, and the server knows that I am requesting for their web page, and they will be replying, and you are getting it. Only that much you know, right? But behind the scenes,
Yes.
actually, it is not the simple topology that you are looking into it. This cable, it is going to ISP to one of its router, okay, and it is not one router they have. They might be having multiple routers,
Mm-hmm.
okay, in the form of mesh or
Mm-hmm.
something like that. I'll be talking about what is mesh, partially mesh, hub and spoke, fully mesh, everything in our upcoming classes, something like this. Interconnected links, Okay, and this will be going, let's say that you are from America, you're trying to reach this server, might be it is sitting in London.
Mhm.
Okay, so you doesn't know where it is sitting, but this ISP routers know where they are sitting.
Mhm.
So let's say that now it will be taking the path something like this, which is the shortest path to reach the Google.
Mhm.
And maybe when it is coming, the reply is coming from the Google. Let's say that this particular link is down, this path is no more available, then this router know how I can switch back my network to
Mhm.
connect back to you.
Mhm.
So this all mechanism is happening within the ISP when
Okay.
one link is going down or going up.
Mhm.
Okay, so this is what I want to say. The before showing all this router, the rough information what you had, only your laptop, Wi-Fi, ISP, and the remote servers is a logical topology.
Mhm.
Okay, it does
Mhm.
not give you a detailed information how the network look like.
Right.
But physical topology gives you the nut and bolt of the complete network diagram. Okay, so
Okay.
that means like this port is connected on which port of this particular router, might be 0/1, the port number, and this link is connected on 0/2 port number. Don't worry
Mhm.
about it. What is that 0/1 or 2?
Mhm.
I'll tell you. No, I'll tell you in upcoming classes. It is
Mhm.
just a name of the port. One router
Okay.
have multiple ports like this. As of now, I don't want to confuse you, so that let me just name it like one port, two port, three port, something like that.
Mhm.
Okay, so in physical topology, you'll know actually what type of cable is used and on which port of the router that cable is connected to,
Mhm.
and this router is connected to which router, and between these two routers, how many distance they are apart from. All
Mhm.
these details. Okay, it is not a
Mhm.
rough diagram. It is a complete diagram, complete topology information that you'll have about the network.
Mhm.
So that means physical topology is the complete information about the network diagram. So logical topology is something you'll have only a rough diagram about how the traffic goes and where it comes from. Only that information you know. So
Mhm.
let's say that now you got hired into a company as a network engineer, and you want to troubleshoot a issue, okay, of the network
Mhm.
issue. So which topology that you'll prefer to troubleshoot, either logical or physical?
It will be physical.
Yeah, exactly. With physical only we can identify the exact issue, not with the logical topology. Great. So again, there are few. Let me just delete this. This is one way of this is one method that we can explain the differences between the physical topology and the logical topology. And also there is one
Mhm.
more way that we can explain these two. Again, there is a difference.
Mhm.
Don't get confused with this.
Mhm.
Okay, just stop me if you have any
Mhm.
difficulties understanding this.
Mhm.
And let's say that now, okay, I have multiple routers here,
Mhm.
and there are multiple switch here, and they are connected like this, something like this. Okay.
Mhm.
Okay, being a human, how I am looking into this network, okay, that means how they are physically connected. Okay, which
Mhm.
wire is going to where and which device is connecting to what, and this
Mhm.
is called as physical topology.
Okay.
Okay, being a device, how the device is looking into the network, right? Getting my
Mhm.
point? That is a logical topology. From the device perspective, the logical topology, being a human, how we are looking the network with our naked eye, is a
Mhm.
physical topology.
Mm.
Is there any difficulties? No, right?
No, it's okay. Yes, keep on.
Yeah. So in this physical topology, I can again, there are multiple classifications. One is like attack. technology called bus, and one is like like ring, and one is S char. Okay, so in bus
Mhm.
technology, actually, it was used in very olden days. I'm not sure whether you have seen it or not, but to be frank, I haven't seen it. In my experience, it is like that in our might be 20 years back or something like that
Mm,
it was. So
mm,
just I'll tell you what actually it does. In bus, actually, like there will be a one straight a copper cable, which is a
mhm,
coaxial cable.
mhm,
In that, at the end, there will be having like terminators,
mhm,
and at some point of this bus, they'll have connected the connectors. Okay, from this
mhm,
connectors, actually, this the cable will be leading to supercomputers.
mm.
That means the mainframe computers.
Yes.
This mainframe computers will be having something called a NIC card, network interface card, which is
Mm.
something similar to what we have nowadays in the laptop, right? Where we are
Yes.
connecting our Ethernet jack,
Yes.
right? So that NIC card actually has a MAC address. Th-
Okay.
Okay, this NIC card actually have something called a MAC address, which is a physical address, or also which is called as a burnt in address. When a manufacturer, let's say that if you are using Dell or LG or HP, based on that manufacturer, when they have manufactured this particular NIC card, they will inject that physical address to that NIC card, which is
Mm,
unique throughout the world. Let's say that if you have a NIC card in your laptop, if you have a MAC address in that, which is unique only for you, it is not for others in that world. That
mm,
particular MAC address is just with you only. It is
mm,
completely unique. Okay,
mm,
this is how the bus technology it was. Let me name it is just like this mainframe as A, and this is B, and let's say that this is C. And
mm,
if you put some data, let's say that if A want to send data to B,
mhm.
okay, when you start sending it, uh, it will be on the bus now, and it will be sending, and this will be going to B, but it is not only going to B, it is also going to C.
Okay. So
Okay,
it's not regulated basically
exactly. It is just flooding that out through the complete bus cable,
to all the end holes. Yeah.
all
Mhm,
the end hosts. Exactly right. Okay, so it is something similar to okay. Just think of it. You are just sending a post to one of your friend through the
mhm.
envelope. That envelope contains what are the things it contains? One, it contains like the from address from where actually you are sending.
Yeah. Your name,
Yeah,
address,
exactly.
postcode.
Exactly. And also to the you are mentioning like your friend's address.
Mhm,
In that
mhm,
name will be there and where he lives, and
mhm,
also there will be a zip code of it. Everything it will
mhm,
be there.
mhm.
Like this, can you consider this a from address and this is a to address?
Okay.
Okay. In the same way, in networking also, when I want to communicate with anyone, there will be something called a source address and
Source address.
source address.
Source address. Okay.
And
And then destination. Yes.
yes, exactly,
Mm,
destination address, right?
mm,
So again,
mm.
when I'm
And
talking about source address, it will be there are two addresses actually we will be speaking up with. I have told you one is a MAC address which is associated with this particular NIC card,
mhm,
right?
and
I'll mention as a MAC address, and also
and
there is
port
something
number.
called a IP address, which is
IP
a
address.
logical one, which is not stagnant. We can change however we want based on our requirements. Okay,
Right.
so these are these two addresses that we use to communicate from node A to node B. That means from sender to receiver.
Yeah.
So
Yeah.
the source address actually what they have is combination of both IP address plus MAC address.
MAC address.
Okay.
Okay.
Also, when I mention the destination address, I'll mention, uh, okay, what is my destination IP address, and also mention what is my destination MAC address.
MAC address. Okay.
Okay, this is how actually it looks like. And if you see actually the data, how does it look like is the payload when we are sending the data, how actually it look like is, mm, let's say that here I'm sending the data from mainframe system A,
Mm-hmm.
A's IP address, which is source IP
Okay.
address,
Mm-hmm.
and then I'll be having B's IP address.
Mm.
Okay, so IP address
Mm.
part is over. Now I'll mention what is A's MAC address. Then I'll mention what is B's MAC address.
Mm.
After this, I'll mention my data or payload, however you want to consider. So
Mm-hmm.
this is how actually uh, the data format which looks like when you are sending the data from your one machine to the other machine.
Okay. Yeah.
Clear?
Mm-hmm.
Okay, fine. So in this, let me consider the MAC addresses AAA as of now, and here the MAC address is BBB, and here let's say that MAC address is CCC. And for example, as of now, let me give the IP address is 10.0.0.1, and here the IP address is 10.0.0.2. Don't confuse with what it is. I'll be explaining you later.
Mm.
Just as of now, just look into it as IP address and that's a MAC address. So
Mm.
when A is sending a data to B, it something looks like I have told you A's IP address, which is after sending my source address 10.0.0.1.
Okay.
Actually, first it will mention what is the destination IP address. In that case, 10.0.0.2, to whom actually I'm sending.
Okay.
The
Just
source
put,
comes.
if you can put S in front of it and D at the end of it, so it makes more sense. I know it.
Yes. Okay.
Okay. So
So
first
now,
it will go as source address and then destination address. If it's coming back, it's gonna be destination and then source. Yes, is that what you're trying to say?
no. Actually, first it will be only it will mention destination address to whom I'm sending.
Okay,
Then
okay,
it will be the source. Okay.
okay.
So now the destination MAC will be what? BBB, right?
Mm-hmm,
The source MAC address will be AAA, and
mm-hmm.
actual data what I'm trying to send. This is what the message now the A will be sending to B.
Okay.
So uh, now once this data is sent on that wire, this will be going to B as well as C.
Mm-hmm,
When B receives that, now it will be looking into this data, and it will check at first what is the MAC address that the message has. Okay, destination MAC address is BBB. Is that me? It will cross
mm-hmm,
verify that. Yeah, it is his bank
mm-hmm,
address. If it is true, then again it will check what is the destination IP address, whether it is same or not. So here it is 10.2.2. Yeah, it is same. Then he
mm-hmm,
agrees the received data is for B only. Then he will take
mm-hmm.
up the data and he'll do whatever the data is like meant for. When it received
Okay.
at C, it will again check for the destination MAC address is BBB, but I am not BBBB, right? So
Mm-hmm,
what he
mm-hmm.
does from this check itself, it directly discard that message. He won't see
So,
what is the IP
oh,
address and what is the data.
so it will just drop it basically
Exactly.
because he can clearly see it's not matching his data basically.
Yes. So this is how the hackers are taking the advantage. When the situation is some,
Ah,
got it?
mm.
Yeah.
Yes,
Okay.
it's making sense to me now.
Okay. So actually, now once B got that data, what actually B does, okay, now he need to, let's say that you send me hello. If I don't say something, what do you think? Maybe I am on the line, or maybe I'm not in the line or playing PUBG or something like that,
Yes.
right? So I need to acknowledge your message. Then only you understand that okay, he is receiving. Oh, sorry, he is listening to me.
Mm-hmm.
So what B needs to do now? B will be replying. How he'll be replying is now he'll put okay to whom he is replying. The IP address is 10.0.0.1, and what is his source IP address, which is 10.0.0.2,
Two.
right? And what is the destination MAC address that he is going to send? How he knows that? Why? Because he just now received from the data, right? The
Mm-hmm.
source MAC address AAA.
Mm-hmm.
Now that becomes the destination.
Right.
And who is the source now? Sorry.
BBB, and it becomes the source.
Yes, BBB, right? And what he
Mhm.
sent now? Acknowledge data.
Okay. So he's saying hello back as well.
Exactly. So
Uh,
what happens with this message? When he put that message, it goes to A and also it goes to C,
mm-hmm.
right? In this case,
Yes.
what A does, he'll check the the destination MAC address. It matches.
Yeah.
Then it
It matches. Yeah.
check the destination IP address. Again, it matches. So he
Where
takes
it's
the
coming
data.
from. Yeah. Mm.
But what happened with C? He'll check at the MAC address and it does not match.
Mm-hmm.
And at that first point, he'll just discard that data.
He just drops them. Yeah.
Yes.
Okay.
Basically, this is how the communication happens in any networking
Behind the
platform.
scene. Yes.
Yeah.
Behind the
Okay.
scene. Okay.
Exactly.
Yeah.
So these networking devices, what happens with the bus? Actually, bus can support only the speed of 10 meg. So
10 meg.
which is
Okay.
yeah. So and also it is a half duplex. What does it mean by half duplex? Is like let's say that if I am talking like in this particular channel, that means WebEx, there are three
Mm-hmm.
receivers. One is Abdul, one is John. Okay, when I'm
Mm-hmm.
talking to John, Abdul need to be silent. Okay,
Mm-hmm.
he should not raise some question to me. Okay,
Mm-hmm.
if Abdul is talking to me, John should be silent. Or if John is
Mm.
speaking with Abdul, I should be silent. Anyone
So
can
it's
communicate in
okay.
that media.
So only one any time as one person at a time you can't. So that's half a duplex. So full
Yes,
duplex is where multiple can work at the same time.
both can speak at a time
At the
because
same,
I'm
yes.
to handle the data. Okay, what happens in a half duplex if A and C at a time started to talking to the B? Then there is something called collision can happen.
Yeah.
Okay, and how we can avoid the collision by using some technologies called uh, CAT, multiple access collision detect, CSMACD.
CSMSCD. Okay.
I'll tell you what it is later. Okay,
Yeah.
so let me finish up with the bus. So in this
Mm-hmm.
bus, what is the major, like caveats? What we have observed was like when they are adding more number of end hosts, the speed, the data rate get
It
reduced.
cannot. It gets reduced. It's only 10 meg. It can't handle. It can handle what you call it,
Exactly.
big work. Yeah.
Yes, exactly. So in that case, they cannot have multiple end hosts. And also the another caveat, it was like, let's say that if there is a issue in that network, it is hard to troubleshoot. They cannot find it that easy to identify. Okay, the issue is here or here or here. Why?
Oh, okay.
Because all these connectors need to be checked manually,
Manually.
independently.
Okay.
Yes, and also they need to check whether the cable is good everywhere. So
Yeah,
this,
that is hard work, man.
yeah, it is so simple to say, but it was not that simple in that days. People
Yeah,
were
back in the days, I know because technology wasn't grown yet, innit? So you have to physically go and lie there and check all the cable trees, everything, innit? It's
ex-
hard work, man.
And also, if there is a break, if the physical bus got broke,
Okay.
either becomes one network into two different network, okay, or the complete network may go down. Why I'm saying is that is, in this case, okay, A can speak with B and B can speak with A, but A or B cannot, they cannot speak with C.
We see. So there's a break in there. Mm.
Yeah, so one network becomes a two network, or sometimes the complete network may go down. Why? Because if there is no B at all, only A and C, both cannot communicate each other.
No.
So these were the caveats, and this was the first technology that we have used as bus.
So that's why now we have switches which can determine and be able to channel to the other devices to be able to speak to the others. Yeah.
I'm not talking about a switch or a
No,
hub.
I'm talking about now in this day and age that we're not using bus